Hi guys, in this video I'd like to talk about the difference between a series circuit and a parallel circuit, just using some really simple examples. So first of all, let's have a look at series circuit because they're a little bit simpler. So if we have a look on the right hand side here, we've got a battery that's got a wire going from the negative terminal into a light globe. And then we've got a wire coming out of that light globe and into the next one, and then back to the battery. So this is what we call a series circuit, and there's a diagram underneath here. So we've got the battery going around through both the first light globe and the second light globe. In a series circuit, every electron that comes from that negative terminal of the battery has to go through both light bulbs. So it has to go in to this bulb, light up this bulb and provide some energy, then go through this one, provide some energy, and then keep going. So we are having to push every electron through both of those light globes. That means that the resistance of that circuit is going to go up. Now we know that if the resistance of the circuit goes up, then the current going through the circuit is going to go down. Now if there's less current, the light bulbs aren't going to be as bright. So those light bulbs are going to be less bright than if you just connected them individually to the circuit. One of the disadvantages as well with a series circuit is if one of these light bulbs happens to blow, like the filament burns out, like what might happen at home, then the whole circuit is out of action and no electrons can get through. So it only takes one light bulb to blow and neither of them will work. So series circuit is very simple, but there are some disadvantages. Let's have a look at a parallel circuit as a comparison. So in a parallel circuit, we've got the battery connected here, and what happens is that when the electrons leave the battery, they actually have a choice. They sort of get to this point here, and they can either go up through this light globe and then back round to the battery, or they can go down this wire here and go through this other globe instead, and then eventually come back up through the circuit back to the battery. So remember, electrons, they'll always take sort of the easiest possible route, and in this case the easiest route is just to go through one of the globes and then back to the battery. So each electron only has to go through one light globe before it gets back to the battery, and we can see that on the circuit diagram here a bit easier, that when the electrons come out of the negative terminal, they can either go up through here or they can go down through this way and then back around. That means that because the electrons are only having to go through one light globe, the resistance is the same for that circuit as if there was only one bulb. So the current is actually the same through both light globes. Okay, and that means that the bulbs are able to shine just as brightly as if they were connected by themselves. So parallel circuits are a little trickier to set up, but they're actually a lot better in a way because the globes will always light up the same no matter how many. I mean, you could add a third light globe down here as well, and it would be just as bright as the other two. And it turns out that parallel circuits are actually how circuits in our house are connected up, because you guys know that it doesn't matter how many light globes you've got in your house, they're always going to be just as bright. So parallel circuits make a lot more sense that way. And also if one of the light globes was to blow, the other two globes would work just fine because the electrons could go through there instead. Okay. I hope that makes sense and helps explain why the two circuits are a bit different to each other. Thanks for watching.